So welcome.
Oh, thank you.
Thank you very much.
This will be quite the conversation, I hope. We'll see how it goes. So Brent, if you could kick us off, a brief overview of cryptography for the audience, and so just kind of set the baseline.
Okay, so the way I like to think of cryptography is it's the way you protect information when it's not physically secure. One maybe simple example about this is I think about a laptop and laptop theft. Now, if my laptop gets stolen, there's really two consequences. One is that I just have to buy a new laptop, or maybe have NTT buy one for me. That's actually
that doesn't happen very often.
Yeah, not too much. But that's actually the least important one. The more thing I'm worried about is that all this information, my emails, browser history, you name it, is sitting on this laptop, and that's what I'm really worried about if something like that happens. So for this reason, in most systems, when you type in your password into your laptop, it also creates an encryption key for it and encodes the information on the laptop that when, let's say, the thief gets a hold of it, hopefully not, of course, but if it happened to get a hold of it, won't be able to make sense of it. So this is one example where the laptop is no longer physically in your control, but you're able to do something you just wouldn't be able to do otherwise.
Right, so it's all about the data.
Yeah, it's about the data.
Okay.
Correct.
All right. So let me follow up with a question, and really this is about the lab itself, and the difference between, again, baseline, the difference between basic research and developmental research, as an example.
Yeah. So there's a lot of things one might call research, right? You say I'm researching this. Developmental research you might think of as, let's say you have a product and you need to have the next iteration of it down the line, perhaps like a vastly different version of it, might be very challenging, have a lot of innovations, not just turning the crank. And in that sense, you need research, but I more think of that as developmental research, kind of pushing out the next thing can be very challenging. Basic research, maybe in contrast, is really driven by, does it change the science, right? It might be motivated by practical examples. We might, and also an extra might lead to things that go into practice. But your first thing in your mind is like if there's kind of a basic or intriguing question, driving, intellectually a challenge, I want to know about this. This would make me change the way I think about things.
How do I get to the moon? Question, right?
Yeah.
All right. Okay, so got sort of the baseline check now. So let's talk about the research labs, and specifically the building of the Cryptography and Information Security Lab, CIS, what we commonly refer to it as NTT Research. Kind of what it took to get there and where it's at today.
Yeah, it took a lot of effort to get it to this place. I think the first guiding philosophy we had was that, or I thought of, is we want to get the best people. So our mission is to become the strongest crypto research group, whether we're or produce the strongest stuff, whether we're talking about universities or industry, right? And in order to do that, you have to get the right people. There might be some task that it's just it takes a certain level of insights or such, and maybe you need this person to be able to do it. You can get 10 other people, 100 other people, it won't get the job done. So the first guiding principle was, can we, how to get the top people, put the resources in there to do it. Second, so in order to do this, I'd say, and we have a lot of great people like Elette here and other people who are in the audience. So to do this, we first have to go for the top people and be willing to put in the resources to do it. Second, we're trying to compete with academia. This is where, let's say, professors don't want to be in cubicles. They want to sit and think their big thoughts, hopefully in offices. So kind of a little bit of a culture change from maybe a little bit of different of industry. And so we really worked hard to set up that environment. Our CEO Kazu Gomi was very supportive of us. And it's been a long road, but I think we're doing pretty well.
Okay. All right. So, not to leave you out of the conversation, Elette, but I wanted to get sort of the baseline set up here.
Of course, yeah.
So you're coming from outside, from a formal university environment into here. So to key off what Brent was talking about, what about the freedom and exchange of ideas? How are you translating coming from academia into an industrial research capability?
That's right. And I think actually ahead of time, I wasn't fully sure what to expect. There's a lot of different environments in industrial research labs, and I've been really, really pleased with what it is. In some sense, to me, it's taking a lot of the benefits of academia, the freedom of research, kind of putting the trust in that somebody's not coming and telling you this is the next step you need to do, but really, getting a pool of experts and letting them view what do we think is going to be the next direction of real excitement. And it's allowing us to really put the focus in the research instead of, there's a lot of stuff that you have to do in academia that's on the side, committee work, this and that. Teaching, for example, is a wonderful thing, but in some sense, for example, in introductory computer science class, probably there's a lot of people that could teach this very well, but there are very few people who can try to develop these directions of research.
So take the next step.
Exactly, kind of.
Okay. All right. So with that said, Brett, what's sort of the difference between running a basic research lab for a corporation and what is the value? So we've got Elette telling us the difference between the academia. So what's the value proposition?
Okay, yeah, I think it's a good question, and and one especially with people from different parts of NTT
Right.
coming in around here. It's what we do is we're not developing products. So first to kind of we're not developing products directly. A lot of our work does become publications, goes out to the public. I think for value for the industry, it's a couple things. Number one is it lends a certain type of credibility to the lab, or sorry, to the company as a whole. So if they're building, let's say, an encryption product, like attribute-based encryption they've been trying to push out, it helps, I believe it helps to be able to point to different people and say, hey, we have the experts here. Instead of just believe us, we're good, I think it allows them to do this. And one point I wanted to emphasize also earlier is that for establishing this credibility, anyone can kind of self-declare that they're a great lab, right? Self-congratulate, self-declare. But what we're going to do is we emphasize being able to do measurable by external success, like in terms of like there are conferences that are established as the top cryptography conferences, and our goal is going to be to have hopefully the biggest presence there of all research groups. The second thing I would say is that there's always, okay, what is the next big idea? Like, right. I hear a lot of times that this used to be a landline telephone company at some point in time, and you can't rely on that today, right? So I think it's that basic, developmental research is good, but I think for something to like really, really get away from where you are, or give you a really different opportunity, you need to step back.
So just to come back to that, so the freedom of execution, if you will, right? So academia, you're really focused on the study, but you guys are producing documents, papers that are going to drive the next set of technologies, correct?
Yes, definitely. And actually kind of a combination, a follow-up to the previous question. Another difference between perhaps, so I've talked a little bit about similarities with academia. Also, there's significant differences. So, for example, if you look even at top universities, the cryptography group will maybe be one or a couple people. Here we have a powerhouse. And I think even just having everybody there together, the interaction, you walk down the hall, you ask the world expert some question about something, and then you start chatting over coffee, and you start developing one of the next directions of research that can really lead to a next big thing.
So you're not being confined to your sort of specific talent or specific area of expertise. You're sharing knowledge. Exactly.
There's a lot of collaboration that's happening within the lab. It's really a fantastic place to be.
Great.
Yeah, and I would say, just to follow up a little bit on Elette, there's been other big cryptographic groups, but I'm not sure there's been this many people kind of in one, or at least in recent memory, let's say, one place who are publishing at the top places, or I think it is something that sets us apart.
It's very special.
Hopefully.
We're going to get a little bit more to the specialty, but the differentiation here is very large. We would say, from a business perspective, that the differentiation is there, the value statement is there. Okay, so let's talk a little bit, Elette, about what kind of research you're kind of specializing in right now since you've joined NTT.
Yeah, this is a question you ask a researcher to talk about the research, and I could go for days here. But maybe just to give a little bit of an idea of a general area of research that I'm particularly working on is what's called secure multi-party computation or secure computation. So the goal is, say, each one of us has some secret information, our health data, our financial interests, and we want to learn some joint global, say, statistics or information across these private data sets. Is there some way that you can do that without needing to actually give the data to any central location, any central authority? So you can think of tremendous application settings here, hospital research, a lot of different financial sector, different things. And it turns out that you can. There are ways, and I remember when I first was learning and developing these things, it seems like magic. How can somehow we learn this information without ever telling or needing to kind of put our personal data out there? So this is a direction that we're working on. The answer is yes, you can do this, but it's still pretty expensive at this point. So we're trying to, we really need to develop new foundations, new different approaches for how to do this sort of thing in order to make this a solution that can be widespread and used in these different settings.
So with that, let's talk a little bit, Brent, and that's a good segue into what is the art of the possible? Right? Mm-hmm. Where are we going to go next? I mean, you talked a bit, just briefly about attribute-based encryption. Mm-hmm. So that's exciting for a lot of the security professionals in the room because that's going to change the way we do business. So talk a little bit about sort of the advances of what's possible next.
Sure. I think with attribute-based encryption, it's kind of this story that's evolved over a bit of time. So when I was a graduate student, I was working with my advisor, Mitsuhai, and there was something called identity-based encryption out there where you can encrypt to just an identity, like right. Who you are. And one thought I had, I kind of was into at the time, a little bit thinking about these biometrics. And I thought, well, what if, but when you measure biometrics, each time you measure it, it can be a little different. So you want a little bit of error tolerance.
Right.
So I said, what if you could have identity-based encryption, but have fuzziness or some, they use the word
flexibility?
Fuzzy. Flexibility, yeah. So there's like 100 features. Let's say you encrypt, they first take who you are, get 100 features. Next time when you get your private key, they'll get 100 features, but maybe 90 of them will work out because, okay. So there's like kind of threshold, at least 90 of them. So that was kind of where, I was really excited about this. That's kind of where it first happened and it first generated. Now it turns out the fingerprinting thing went nowhere. It went nowhere directly. No one talks about the biometric stuff, well, other than me right now, anymore. But then, over time, I guess I matured or started to see things differently. I thought, oh, this is much more general, right? You can encrypt. Let's say you can when you get your key, it can have a bunch of attributes, that label who you are. I work here. I'm this and that and that. And when you encrypt, you can encrypt to a policy. It says, instead of you're pretty much rethinking encryption. Instead of am I encrypting to you, I'm thinking who do I want to have this, and then the encryption sees that the key and the ciphertext agree essentially, right. And so we think out of the box instead of like as a point-to-point thing. So at that point it got in. Took a while. Then it started to catch on in the research sense. It did take some time. It got in at first of the conferences, but I think took some time to become high in people's minds. Right. We have some colleagues who weren't working at first, but now they got excited over time. And now I think that's been the last 10 years. And now what I'm wondering is, can it make it into practice? And this is probably where we've actually pushed the NTT. And in this conference, I ran into multiple groups saying, hey, we're trying to do this, this, and that. Right. So that's kind of the evolution.
So that keys into the next question is, how do we get the fundamental research into the product lines, right? Into actually selling the technology as part of a product revenue generation, in my case, how do we make money on it?
Yes, so that's a great first, I think it's a combination. I'm not the expert on that, but what we have done in this case is we've actually, we got the basic science done, and I helped motivate and hopefully we talked with the CEO, and got them to buy into it. Then we needed people who were then we needed this kind of combination people. Actually, my former PhD student, Yanis Lasakis, is in the audience.
Where you at, Giannis? There he is. All right.
Okay, so he's kind of in the in-between in that he's had the training as a cryptographer, but he's, as much as we like basic research, we need someone who's kind of transitioned to a little, we can't all think high thoughts and, I'll go on a little walk every day. If we want to get into practice, we gotta have people a little different than me, I think.
This is how I do research.
Yeah, long showers and all that, So he has some experience in practice. So we need someone who actually, you can't just get a developer. You need someone with the expertise. So he's kind of built up the library and this type of stuff.
Right.
And then I think the next thing is talking to different operation companies. So now we branch out from there. He has this library, and a lot of people are like, oh, I know this university in Australia that does this, or in Romania, we have this connection. So,
right.
and I think that's kind of the last stage that I hope works out.
Right.
Yeah.
So given that, the relationships and partnerships become really, really important. So talk a little bit about how you are creating those relationships and maybe even fostering those relationships to get to the point where we can start moving this technology into operations.
That's right, and I think there's a lot of different levels and different phases indeed for this process, as you've heard. And this fostering partnerships and so forth starts already really at the foundational research level. So for example, a lot of these developments and ideas, actual creation showing that such a thing is possible to begin with, is due to collaborations not only within the lab, but also with collaborators and partners outside of the lab. And we found that actually at this point, a lot of these are formed pretty organically in a really nice way. We also have programs within the lab to help support that. For example, we have a visitor program that helps bring in experts that are related to our own research to come in, and we can work with them for a month or different periods of time. And also we've seen a lot of different collaborations with the local universities. It's an outstanding area to be, Silicon Valley. Not only do you have all these startups, you also have, for example, Stanford, Berkeley. For example, so there's a Bay Area Crypto Day that now happens periodically on a regular basis. And right now, Stanford, Berkeley, and NTT Research are the three hosts and coordinators of this.
Wow.
So yeah, this is already where we've made ourselves known. People are coming to us. For example, actually looking even at the applications for interns that come, PhD students coming across the country, even externally. We are really getting the top of the top who are coming and want to come work with us in this environment. So this is already, even at the very beginning stage, a fantastic connection.
I think that's great. Also, obviously, promotes the idea about working in an industrial research capability. So more people will start coming. Do you guys branch out into other universities? So you're from Princeton, you're from MIT. Is there other universities like Stanford across the nation or across the globe now that you guys are working with in certain areas?
Yeah, there's I would say plenty of them. And I think this is where maybe the way, I don't know if it's computer science or theoretical cryptography works. Again, it's much more individualistic. You see some physics papers, there's like 30 authors, or biology papers. Here you might see like sometimes single author, 2, 3, 4 type of author papers. And even as the director of the lab, I guess in some sense what I don't do is as important as what I do. Like I don't be like, okay, you're working on this or you're that. The people kind of as they are, just go to conferences and meet people. And that's why Elette was talking about the visitor program. We kind of shifted. I think that works much better because then instead of me trying to decide, oh, if we have some resources that we want to use to engage collaboration, instead of me saying, oh, we're putting this amount, allocating this amount of money here, it's really driven by the individual researchers. They have a lot of input for who we invite over and get these 2 or 3, type author papers, 2, 3, 4 type author papers going.
All right. Here's the part of the conversation that Brent hates, but we're gonna talk about this because I think it's important. Pardon me for just reading somewhat directly here, but so Brent's contributed to a lot of different things in the community at large. But one of the things that I think is important is that he's been 3 times award-winning for the Test of Time Award.
Actually, recently 4.
4. I'm sorry,
okay.
that's
Yeah,
right.
yeah.
Brand new. Now, the audience might not recognize, or the audience outside on the stream might not recognize this, but that's like the security teams at the beginning of when we created, information security. Were you successful 10 years later? Did your stuff really work? Did it really get to the market? Did it really solve the problem? Did it really contribute to security of society? That's what this award is about. So could you talk a little bit about, maybe pick 1 or 2? So.
Okay. Thank you. Sure. So as you said, this is like and depending on the one, some of them are maybe like 10 years in retrospect or 15 years. So when like best paper awards are given out, it's like, what do people think at the time? And this is, in some sense, made with the benefit of hindsight.
Right.
So it's been so 2 of them have been related to this attribute-based encryption stuff that I already talked about. I won't go into too much more again. One of the most recent ones was on something called obfuscation, or a certain type of obfuscation. And so the idea of obfuscation is where I have a program, I want to be able to give it to you so you can run it and use it, like without my help after I give it to you. But I don't want you to be able to look inside and figure out exactly how I did it. So maybe imagine there's like some artificial intelligence, machine learning type technology in there that should be used for this purpose. And if I just gave you my code as it is, you might use it for this purpose, but also kind of dig in and say, oh, look at the training data and maybe repurpose it to something else. Yeah, you could do that. So is there so the question was there a principled mathematical way to be able to go about this? And at the time, we put, I guess about 10 years ago now, just over 10 years, we put forth the first kind of, I guess you could say, mathematically based system. And there's been a lot of improvements, other work since then. And I think one of the things is just how many works since then have really built on it, taken it in new directions.
Been successful, right?
Yeah,
at the end of the day, right? That's pretty insightful, right? So, you're using hindsight to say, hey, we were right in this theory, and it came true, right? And that's it's not possible in every part of the field, right? So it's very, very good. So congratulations on that again. So let's talk about a little bit about research and contributions that are driving home for the company at large. So I think you said in past quote, this paper opened up a whole new world with beautiful new ideas, Elette. I think that's your quote.
Said that, yeah.
And showing not only that this object may be possible, but just how useful and important it can be. So talk a little bit about that. So we'll give you a little ray of sunshine here, and please.
Yeah, no, actually, I'm glad I'm pushing Brent aside because you're being too modest. No, really, this work coming from the perspective of another cryptographer, this was something that we thought was not possible. I think for years it had been considered, okay, there's this goal of obfuscation, but don't worry because you can actually achieve it mathematically. And when this paper came out, I remember it really changed everything. It changed the perspective of not just even the specific goal, but so much around it, of how many different places this could be used and in different ways. And it's just a tremendous sort of clever approach where they backed off a little bit on what the thing was that was achieved, but showed that this was still enough. And that was part of the surprise for everybody.
Right.
And actually, I do want to say that maybe kind of going back to the question of the art of the possible and so forth, this is a perfect example of that. This is something where, in some sense, you guys said, like, look, everybody thinks this is impossible, but I'm not deterred by that. Let's make this happen. And I think this is some of the beautiful, kind of really exciting part of foundational research, that you can start making these big steps and then see down the line where all the things that this will affect.
So again, just a question coming out of that conversation, for us in an industrial research lab, is that something that's attracting the talent that you're looking for, the ability to think about what's possible and actually then see it come to fruition?
I mean, I think so. In some sense, what I believe is attracting people is that just the freedom, and essentially that we have here. We do some marketing, do this, but most of your time, if you're here, is going to be spent on thinking, like just which is thinking, writing papers and putting it out there. And I think what attracts people is also seeing other people who are like them. Maybe perhaps Elette joined us not too a little while ago, but there's some people who came before her, and probably seeing, okay, well, if this person are happy there, I'm probably going to be happy there. Putting words in her mouth. But.
Yeah, sure. But actually, in addition to that, so I think over time, I started my training is in pure math. I came from this side, and I'm beginning more and more, push toward practicality as the years go on. But indeed, this is what, in fact, drew me to cryptography, is that it's got the beauty of pure math, but it's not just on the side, totally disconnected from the world. That these things that we're developing have a goal, that they have a potential path to make a difference.
Well, that's fantastic. I think I want to try to leave a couple of minutes for questions here, but just some final comments from both of you, and then maybe we'll take some questions from the audience. So what about the future of cryptography? What does the future look like? I mean, you're talking about the art of possible, and obviously you've proved some of your theories and they've come true. So what's next? I mean, what is next? Go ahead.
No, just first of all, I'm so curious to find out. I think that in some sense, so cryptography, as it stands now, it's everywhere. This really was enabling us to have e-commerce and everything as we know it today. And I think that with all the changes that are happening and all the shifts, that really there are so many different cryptographic challenges that are coming in. And so seeing what is next, I don't think we have necessarily the answer right now. There's a lot of amazing directions that we see. I mentioned just one of them with the multi-party computation,
right.
All sorts of advanced abilities. Obviously, there's a lot of challenges and interactions with artificial intelligence that are coming in. This is something that we're really just, getting developed.
Okay.
Really just tremendous opportunities.
Yeah, so one thing I'll mention, this is a little more on the theoretical side,
right,
but
right.
In cryptography, what we do usually is we have to assume some problem is hard, like difficulty of factoring, something like that, and then we build stuff from it. So we build something new and say, well, we don't know, this will be secure as long as this problem is hard. And one goal is to move the thing you're assuming to be smaller and smaller and more believable. And I actually see us, this is kind of really big direction in the 80s and 90s. And in some ways, I kind of hope us to return to that. Again, this is, and maybe slay some of the, to be dramatic, slay some of the dragons that, we weren't able to before. So that's a little bit, it's a little bit further away from, okay, let's get attribute-based encryption out there. But,
right.
Some of my heart's in seeing that type of thing get solved.
So just a final question as both of you were talking. What are we going to do about cryptography now that we're increasing the speed of data transmissions, right? How is that going to how are you looking at that right now? I mean, attribute-based encryption should be somewhat of an answer. That's going to be giving us some flexibility, but are we going to be able to do it at the speed of light? Maybe I shouldn't put you on the spot.
Yeah. Sure, yeah. I'm just kidding. I think for the most part, for like public key encryption, you can, encrypt some symmetric key in this way.
Right.
And then, so use your advanced stuff, which might actually be a little slower than even more slower than public key encryption, but then do that first step, and there's something called hybrid encryption, where then you can use your fastest stream cipher or AES in order to do it. And after that, it's up to the hardware people to parallelize it. There's things to parallelize. And
please get together with these folks. They'll be around. Spend some time. Thank you guys very much.
Thank you.